In this video, we're going to be talking about constructors. And there are a bunch of different types of constructors that you can use depending on what type that you're attaching the constructor to. A constructor is basically a way to initialize an object to a particular state in order for that object to be used in the future. So I'm going to go ahead and fire up a new project and show you what some of the constructors look like. Now, like I said, there are a bunch of different types of constructors, and the type of constructor that you're using depends on, especially on where, what type of type you're using. So, for example, a struct constructor is going to be very different from a class constructor.
Okay.
So let's go ahead and create a class. And you don't see it here, but the compiler is actually generating a constructor for us even with this code. And I can prove it to you by using the new operator. The new operator is a way that is the only way to actually access a constructor. So you see that we are instantiating a new my class with the new operator, and we're passing in nothing. This is actually executing the default constructor, which is created by the C# compiler if you do not have any other constructors defined on your class.
Okay.
Now, in order to provide your own construction logic, you can go ahead and create a constructor by creating a method, or what looks like a method, and giving the method name the same name as the enclosing type, in this case, my class. Now this is, again though, this is the only way we can access this code. Constructors cannot be accessed directly, and they cannot be named anything different. Now, and they cannot return anything. Now, in addition, you can attach attributes to constructors, and you can give your constructors different access modifiers. And that comes into play when you're dealing with inheritance. Now, as far as class constructors go, there are a lot of different rules that you have to keep in mind when dealing with them. And so I'm going to go ahead and create an inherited class. And then instead of instantiating my class, I'm going to instantiate my child. Now, I'm going to put a console.writeLine in here inside the parameterless constructor of my class. Also, just a quick aside, CTOR is the abbreviation of constructor. So if you ever see me use CTOR, that's what I'm referring to. Mm-hmm. Now, this will actually have some interesting behavior that's definitely worth keeping in mind, and will have implications when dealing with inheritance hierarchies. So let me go ahead and run this code, and you see my class CTOR is being invoked even though I'm not directly calling on that constructor.
Right.
Now, what you might assume is that constructors are inherited, but this actually is not the case. If I were to create a constructor on my class that took in parameters, so for example, if I were to do this and try to instantiate a my child with an integer as a parameter, you'd see I get an error. So this sort of proves that these constructors are not inherited. So what's going on in this case, where the default constructor is being invoked? And that has to do with the way the C# compiler will generate a constructor if none is defined on the class. It'll do something interesting. If I were to write out in longhand what the generated constructor of my child looks like, it would look like this. Now, what this is doing is basically every single constructor inside of my child must always execute, or must always invoke, a constructor of the base class that it immediately inherits from. Now, you see that the C# is telling me that this base is redundant, in which it is, but if I were to remove this base, it would have the same effect. The default constructor of my class will always be invoked. Now, this base is very important when the class that you're inheriting from does not have a parameterless constructor. Mm-hmm. So if I were to go ahead and comment this parameterless constructor out, the only way to construct a my class is to invoke this constructor. Remember,
meaning you have to feed in a parameter?
Exactly. Because remember that the C# compiler does not generate a default parameterless constructor if you have any other constructors defined, in which case we do. So now into the base, invoking the base constructor with this syntax, I have to pass in an int parameter because that's the only overload on my class that we have access to. So if I pass in a 10, it'll be happy. Also, if I were to remove this constructor entirely, I will get a compiler error specifying that it doesn't contain any parameterless constructor. Or
basically it's saying you've got to do this with a parameter, otherwise it can't happen.
Right. So as far as the base keyword, this is a very interesting way that you can use it to access your immediate parents' constructors. But another interesting thing to know about inheritance and constructors is the different modifiers that you can use for a constructor. We can have a public constructor. Alternatively, we could have a protected constructor.
Okay, what does that do?
This code will behave the exact same way, but if you remember, protected means that this member can only be accessed by itself and children of this class. So this code is still correct because this child is accessing the protected constructor, but watch what happens when I try to instantiate a my class now. I get a compiler error.
Mm-hmm.
The reason I get a compiler error is because this constructor is only accessible to children of this class, not to external people.
Okay.
So as far as class constructors is concerned, those are the main things that you have to keep in mind when working with them. The other main thing, I guess you should also be aware of is that constructors are invoked from most or least derived type to most derived type. So let's go ahead and make this public again. And I'm going to go ahead and add a console write line to my child. And the behavior of this is going to be interesting because when I run it, you'll see my class CTOR gets called and then my child CTOR gets printed. And that's because, like I said, the constructors will always start from the least derived type.
Okay.
So ultimately, the object constructor is being invoked first because every single class inherits from object.
Right.
So for instance constructors on classes, those are the main points to keep in mind. There's another interesting thing that you can do with constructors, and that's a static constructor. Now, a static constructor on a instance class is going to look like this. It's going to be it's going to have the same name as the enclosing type, and it's going to have the static modifier. It's important to know that you cannot put any other modifier on the static constructor. It must be just static followed by the type name, although you can annotate it with attributes if you wish to. Now, the static constructor is interesting because it's only going to be invoked at a particular time. So let's go ahead and write console write line. And see what the output of this is. So the static constructor gets invoked first, then the myClass constructor gets invoked first, and then the myChild gets invoked last. And what's happening here is that if I were to actually go ahead and remove this code, you'll see another interesting behavior.
Mm-hmm.
The static constructor is not invoked at all.
Yeah.
Static constructor is only invoked once for a non-generic type, and it's only...
Nelson, is everything okay?
Yes, everything is fine.
All right.
Static constructor is only invoked once for an instance type, and a non-generic instance type, and it's only invoked the first time the type is instantiated, such as when we did var object equals new myChild, and it's also done whenever a static member of the class is accessed. So if I were to do this, if I were to add a static member, and I were to invoke that, my class dot, of course he needs to be public for me to access him from main, and if I were to invoke that member, you'll see that the static constructor gets invoked again, and then the member gets invoked immediately after.
Okay.
So you can only have one static constructor. It can't have any parameters. It can't have any access modifiers, and it's invoked whenever a class of that type is or that type is instantiated, or if a static member is accessed. So as far as static constructors on classes, that's about it. As the next few considerations that you have to keep in mind when working with constructors are structures. And structures have a bit of different behaviors in regards to constructors, especially how the C# compiler deals with them at a code generation standpoint.
Okay.
So if I were to have a struct, my struct. Now, unlike classes, a structure will always have a parameterless constructor, default constructor, always. There's nothing you can do about it. And if I were to try to define my own parameterless constructor, I would get an error saying that struct cannot contain explicit parameterless constructor.
Okay, so it's got one there by default. You just can't make your own.
No. And unlike classes, which whenever the compiler generates a parameterless default constructor for a class, it is empty. Structures are a bit different. See, if I were to give this a field, this structure a field, the generated parameterless constructor of my struct is going to initialize x to its default value. And it's going to do that for all of the types that we define as fields inside of our struct. So as of right now, the generated my struct default parameterless constructor is basically just setting x to 0. And again, we cannot access it. Another important thing to know is if we give our constructor parameters, before we can access any member of my struct, we have to initialize every field of that structure. So you'll see right here we're getting an error saying field X must be assigned upon exit. If I were to give this a member and invoke the member within the constructor, you'll see another error. That this object cannot be used before all of its fields are assigned to. I couldn't even print out X if I wanted to, because struct field X might not be initialized before accessing.
Okay.
So remember, in a structure constructor, you must assign every single field to a value before you can either exit the constructor or use other members. So this is as simple as doing this. In this particular case, all I can do is X equals X. And now you'll see, if we try to instantiate my struct, we get two constructors. This is the one that's generated with no parameters, so I could still use that publicly if I wanted to. I could alternatively pass in a parameter to the second constructor that takes in an integer of with the name of X, and that will invoke this code, assign this field, and everything will be good.
Right.
There's one major consideration when dealing with structure constructors, and that is automatic properties. So if I were to give this an automatic property, such as public int x get set, and I were to do x equals x, you'll see I'll get an error. This object cannot be used before all of its fields are assigned to. Now here's the problem. This automatic property syntax is creating a field for us behind the scenes that we can't statically access. There's no way for us to set this field that's being created by this backing field. But we can use another interesting syntax with constructors to get around this, and that is by explicitly invoking the parameterless constructor first with this syntax inside of the constructor, or out immediately after the parameter list of the constructor. So what this code will do is it'll invoke the default constructor that's generated by the compiler, and then it's going to invoke the and then it's going to set the x property to x. So it's kind of like two steps. First, the backing property of x gets set to 0. Then we manually set the property to a value. So as far as structures go, that's about it in their constructors. But static struct constructors, and I know that's a bit of a mouthful.
It is.
They have some interesting behavior in themselves. Watch when I do this. I do static myStruct and declare a static constructor, just like we did with classes, and I put it in a console.writeLine. Now watch this. I'm going to do var stir1 equals new myStruct. I'm going to invoke its default constructor, and then I'm going to invoke its custom constructor.
Okay.
And I'm going to say console.writeLine default invoked. And then I'm going to say non-default invoked. Now remember that we are right-lining out statically inside the static constructor. And we are right-lining out immediately after creating this object and immediately after creating this object. Now watch what happens when I run. You'll see that the code first says default invoked, meaning I instantiated this structure, but the static constructor didn't get invoked.
Yeah.
Because default invoked is the first item that is printed out. Then static constructor is called right here, and then I get non-default invoked. What's happening is a static struct constructor does not get invoked if you instantiate a structure with the default constructor.
Can you say that a second time?
A static struct constructor is not invoked if you instantiate the structure with the default constructor.
Wow. I'm just impressed you could say it again. But yeah, I see what you're saying.
So yeah, in this case, the only time that the static constructor is invoked is A, when we instantiate the structure with a non-default constructor, and B, when we access a static member of the structure.
Okay.
So finally, there's one more thing with static constructors that you have to be aware of, and that is static constructors on a generic type. So if I were to come up here and say class my generic class and give it a type parameter, and then I were to say static my generic class as a constructor, and then I can say console writeLine my generic class of type T static constructor, and then pass in type of T dot full name. And then I were to give this a static member, or maybe we can just go ahead and instantiate it statically. So what I'm going to do is, let me go ahead and clean out main. I'm going to go ahead and say object1 equals new my generic class of type int. Object2 equals new generic class of type int. Object3 equals new generic type of class int. Then I'm going to do something different. Object 4 and 5 are going to be new generic class of type double. Now what's interesting about this is if we run this, you'll see something cool, in that this static constructor is being invoked more than once. For every type argument list that is passed in, for every unique type argument list that is passed into a generic class, the static constructor will be called once. So you see in this case we instantiate 3 my generic types of type int, and that only calls our static constructor of type int once. Then after that we immediately call my generic class's static constructor of type double, and we only get one invocation of that. So that is a consideration to keep in mind when dealing with generic types and static constructors.
Okay. Very cool. So does that wrap things up for this video?
Yeah.
All right. Thank you very much for watching.